In this installation of machine upgrades, we'll be looking at the PocketNC, and specifically the Kinetic Control machine interface that upgrades that environment to make the machine more user-friendly and easier to manage work coordinate systems. Stay tuned. Alright, so today we're looking at the Kinetic Control machine interface upgrade for your PocketNC. Now if you've seen my other videos for the PocketNC, the setup and orientation is all very tedious and specific to get it right before you mill on the machine. Everything's based around the machine's calibrated center of rotation, and it requires you to set up those fixtures and that point of rotation within your CAD or CAM software before you generate your tool paths, because it's all in relation and orientation to that initial machine rotation axis. That can be complicated, and it can lend itself to problems in that your virtual setup doesn't exactly mirror what your physical environment is. Maybe your stock on the machine is off by a little bit, and then the tool paths will be off by that amount as well. There's no way to really compensate with the previous edition of the machine control interface. So Kinetic Control is the upgrade. Right now it's a $200 upgrade. It's available on their website. It's going to be also available in all new products, and I believe that they're not marking up those products with this included for this month or through November of 2021. You'll have to double check their website for the specifics on that, but at some point they're going to raise the price of their products to compensate for this machine interface. Now it's pretty nice, has a lot of features, but I think this is really setting them up for the development and expansion of their product capabilities. What we get out of it today is probably not what their complete vision is, but it does improve the ease of and ability to manage those work coordinate systems on the machine and to make in the field adjustments about the placement of your device in the same way that you do like 2.5 and 3-axis CNCs. So with that, let's dive in. We'll open up the box, we'll look at what comes with the upgrade and then the installation and all that fun stuff. But first we have to open this box. Okay, in the box it's got a lot of packaging, and as you would imagine, it's got the SD card, micro SD card, and an adapter. It's got a bill of materials as well as an installation guide. It's got a few pages which articulates the SD card installation, backing up the calibration files, a couple visuals about the insert there, and a general overview of the interface. That's about it. With that, we should be good to go. Alright, before we can perform the installation, we need to download the machine's configuration data. And for that, we need to launch the existing machine interface, click on the Config tab, then Server, and then launch in a new tab. If you're prompted, you'll need to use the default for the username and password to log into the machine interface. And then once you're logged in, we just need to provide the machine serial number here, 2063 in my case, and click on the button to download the machine specific calibration. With that data, that's extracting the factory calibration data, and we'll need that to perform the install, or at least to calibrate the new installation. And now we can proceed with installing the SD card. Okay, so on the side panel, I've got my PocketNC mounted in the enclosure, and as a result it's difficult to get there. I can't use drivers, so I'm having to use this small Allen wrench to get the 5 screws off of the side panel. Aside from that, it was pretty straightforward. It took some time to work in all the angles. There is a connector to the board panel, and then you just basically insert the micro SD card. You need to have those contacts facing up when you insert it, and then it's just a matter of putting the cover back on with those 5 screws, and that's all there is to it. The upgrade then will now automatically install in the next power on cycle. Turn on the power and you're good to go.
One eternity later.
Before we get too far, electronic projects always start with good circuit designs, and for that I rely on Altium Designer. From simple to complex, if you haven't taken a chance to download a free copy and see what you're missing, I've put links in the description, and with Altium Designer, creating these complex projects is a piece of cake. Through your development, you'll be empowered to do your best work as you grow into its more advanced capabilities. The link in the description below will allow you a free trial version of the software so that you can check it out and see what enterprise class ECAD feels like. Now back to the overview. Alright, so after some time you can navigate to the IP address of your machine interface on the PocketNC. Your screen should look something like this. The lower bottom section you'll see there's e-stop, and that's a large button to release the e-stop. Click on that. Now the machine motors and everything are engaged and active. But before we do anything, we're going to want to go to the config section. Notice there are multiple sections across the top, and we'll speak about the content of each of those. There's setup, manual, production, history, and config. We'll want to click on config. Then we'll want to click on server subsection of config. And now the next thing we need to do, this is the area where you'll download or upload that configuration data that we got from the previous machine interface. We'll just want to upload the file that we extracted from the previous environment. And then you'll successfully update the calibration data. To complete that, then you're going to want to restart the services. Restarting the services will load up that new calibration data. Now, once the machine is calibrated, let's give it some time to restart and reconnect.
A few moments later.
Alright, after a couple minutes, the machine has restarted the services and it's reconnected. You can identify that in the lower left corner. It says connected, and you see that it's now back in e-stop state where it needs to be reset. So we can either press the button physically on the machine, or we can click this button down here. Now that we're connected to the machine, let's talk about this new interface a little bit. To do that, we'll head back to the setup screen and start from the first tab. The setup screen is where you'll set up your work coordinate systems, whether it's G54 or 55 or 56 or G92 temporary work coordinate systems. And that's basically how you zero out the machine. So we never had this capability in the previous machine interface, which is really nice. And this is probably the biggest feature of this machine interface. Now it's huge, don't get me wrong, and it allows a ton of flexibility in how you can set up and configure the work coordinate system on the fly and manage it if you're doing repeat operations, or if you have specific fixtures that hold the product that you mill on the machine, then you can set those up in advance for your 54 and 55 and so on work coordinate systems. Or if you need some temporary work coordinate adjustments, you can manage those in G92. And this interface on the setup tab allows you to do that. Everything's grayed out right now because nothing's been homed. So to get started, we'll first want to home the machine, of course. Homing all will automatically perform that. So it completed homing all access. Other neat aspect of the machine is in the lower left. You can see that it's connected. You can also see all the G codes that are currently active with regard to how the machine is configured and set up. Over on the right hand side, there's some flags. This is an information flag. It tells you the number of messages that you have. And you can see here the only message there was connected to the machine. If you get warnings or errors, then those will also be down here with additional icons, and you can click on those at any time to see what's going on with the machine. So on the setup tab, and this lower footer never changes. That's always there. The reset button will alternate between e-stop and reset, and if you need to stop the machine for whatever reason, you can hit that reset button. Or physically the e-stop button over on the machine itself. Alright, so now that we've homed everything, we have the flexibility to go down here. We can select a specific coordinate system that we'll reference in our toolpath generation over in our CAM software. Generally, you're probably only going to use one, which is probably G54. And then you'll use the post processor in your CAM software will also use 59.3, I believe, for any rotational work coordinate systems. And we'll talk about that a little bit later when we're setting up the CAM toolpaths. So one of the neat things about this interface is this basically allows us to touch off on any surface using a probe or a edge finder, or just using the end mill itself to touch off on your material in any axis, and then identify that and zero that out for whatever coordinate system you're using. The default's G54, so you could zero out your X, Y, Z, A, B, and generate and prepare the machine for a specific orientation in relation to the stock that you have mounted on your machine. So we no longer have to do this all virtually. You can touch them off And we'll walk through that a little bit later. For now, we're just kind of running through this interface. You can also change this for the machine work coordinate system or the virtual work coordinate system if you want to see what the G54 in your DRO as opposed to the machine coordinates in your DRO. So that's kind of up to you. Also, we have the tools down below as we always have, and I believe you can add additional tools down here. Yeah, they're what do they have? 52 different tools if you want to use them. Now, of course, PocketNC doesn't support tool changers, but if you have callets that can hold their length, then it's nice to set these up in advance. One of the critical aspects of note here is that this tool represents the tool number that you'll use in your CAM software when you're generating your tool paths. So these need to match one-to-one, or if you are never going to do more than one tool, maybe you always use tool 1 for every end mill that you use. But just keep in mind that if you're going to select that, then you'll need to measure it as well. And this tool length offset is important for the machine calculating its 0. So you'll need to select your tool before you start to touch off on your X, Y, and Z axis. So important note, in this case, we'll select tool 1. It's automatically going to measure the tool, brings it to the front, allows me to probe it. And as it probes the tool and updates the tool length offset, then you see that designated over here in the offset for the tool 1 that's selected. Now you'll need to select that, measure it, as I mentioned, before you can start setting and zeroing out your axis when you're touching off on your stock material. Alright, we'll dive into that a little bit later, but that's the setup tab. Once you have your G54 zeroed out, and that's the work coordinate system that you're going to use in your tool path generation, then you're good to go. Next is the manual tab. A manual allows you to move around. It also allows you to enter MDI commands directly if there are things you want to do on the machine. You can also enter commands and then select them as favorites, and you do that. You can see this history of commands that I've entered. You can just hit the star over here and it toggles whether or not the favorite is saved. Favorites on the other hand are also down here, and this is going to list all of the starred MDI commands that I've set up. And if you add a name, which is done by just typing in the name, touch work home, and hitting enter, you can also associate a key binding to that, so you have instant macro for that MDI command, as well as anything that has a name will be provided in this quick access toolbar. Now it seems like several steps in that you have to enter your MDI, you have to star it, then you have to provide a name, and then it gets on your quick access. But once you've gone through those steps, this interface is easy to use on mobile devices. It scales well and allows you just to quickly touch it without having to type anything in with a on-screen keyboard or anything like that. So it makes for a pretty nice layout and a user interface. System area also has some additional tests, but settings, but these seem to be specific to factory needs. If we look at the top section where the spindle information is, you notice there's power, load, and temperature, but for the PocketNC 210, these values will not be displayed, so keep that in mind. Nothing broken. I think this is just something that they're planning on implementing in future machines, and they're preparing the interface so that you're familiar with that environment and that layout as a dashboard for all of their machines. So keep that in mind. So it does give you RPM, and you'll be able to use that, and it'll calculate a real-time dynamic chip load. And I imagine that you can then manipulate your feed rate and spindle rate to adjust that chip load on the fly and get immediate feedback, which is kind of a nice option there. Over here on the jog, keep in mind this is in the manual environment. You can set up the DRO to be the the work coordinate system, the G54 position, or the actual machine coordinate system position. And you can change and manipulate these. These all have hotkeys, and we'll get to that a little bit later. But you can change how much you want it to move, whether it's continuous, and then you can also change this from inches to metric. You can adjust these. There's no, I guess you would have to enter the MDI command to set your spindle speed if you wanted to turn it on for maybe an edge finder or something. Production is a similar interface, only this is more locked down. It's not for entering MDI commands. It's mostly for monitoring the G code while you're executing an operation. So in which case you'll want to load up your file, select your file, and you can see the G code down here, and then you basically cycle start, and you could feed, hold, and step through your G code if you like. Step is kind of a neat feature. You can step through it line by line and individual operations. If you have a very tedious or unproven G code that you're running and you want to step through line by line, then you can certainly do that. You can also manipulate the feed rate, spindle rate, and the rapids and velocity, all dynamic in real time, which is really kind of nice. Now, history is going to show you what's occurred with the machine. It's connected, the file was overwritten, lost connection when I told it to restart the services, then it was connected, and then you see I loaded a tool and hit cycle start and all that fun stuff. So you can see the message log of historically has occurred on the machine since the last reset, I suppose. We look at the config section. Now here we have two sections. We saw the server earlier, but the client section is specifically where you will associate all those hotkeys, the key bindings basically, for jogging, and then you can see the default settings that they already have, like equals and minus. You can identify the next and previous access using the quote and semicolon, increase step size or decrease step size, bracket left and right. So lots of great features. This makes for a huge opportunity to create a nice pendant or machine control interface that you can use all of these hotkeys for. You could come up with something really nice like the pendant that I created a while back with the jog wheel and everything. So that's kind of a neat option, as well as you can hit the pencil and modify any of these and associate a key press to any of these particular items. They cover just about any need. Here's in program units, that's going to identify the units based on what your toolpath has been generated for, or you can force it to be in inches or millimeter. Time, minutes or seconds, surface, feet versus millimeter versus meter versus inch, your pressure, temperature, and audio. Audio is kind of interesting or curious thing. You would think, why do you need audio? Well, when you're using these hotkeys, audio provides some feedback from the device, the computer that you're running it on, not the machine, to give you some confirmation that a key's been pressed. And so it's just allows you to hear a little click, and you can turn that up if you like it, or disable it. Language, English, dialect, industry or intuitive. I haven't tried intuitive. That's an interesting option there. And files, you can clear your cache there. So for the client, that's pretty much all of the configurable options there. For the server, there's a few others. Now for this environment, you can, on the server environment, you can shut down the services, reboot the machine, shut down the machine, download the serial configuration or the configuration for the machine. And these are the factory calibrated offsets and positions for each axis of on the machine. Upload, restart services. There are specific settings that you can view. I'm not sure that you can change all of them. You can look at the calibration data, features, tool probe, compensation tables. One thing that's not enabled by default is you can probe tool on M6. By enabling that, if you have M6 commands in your G code, it will automatically stop and allow you to change the tool, which will then probe for the tool length offset and continue your operations. Generally, it's two mindsets. If you want to separate out all of your toolpaths and manage that manually, you can do that. But if you want to do it on the fly, it will respect the M6 command in your G code, which is a nice option. That's it from the front end side of things. So let's step over back into Fusion 360 now and look at what the process used to look like and what it looks like now using the Kinetic Control. All right, so over in Fusion 360, we're looking at a couple miscellaneous projects, and this will show you sort of the difference in how we set up and prepare to run on this Kinetic Control interface as opposed to the traditional or previous method of doing it where we're referencing the center point of rotation on the machine. So generally, if you had something like this, here's a ring, Mandalorian ring, you couldn't just go into manufacturer and start to run setup because there's no way to identify, well, you could bring in models that represent the machine, but there's no way to identify the center of rotation. So what PocketNC provided at that time were machine fixture plates, and these are, in this case, this 25 millimeter collet, which was what this was milled out of, 25 millimeter dowel, basically. And so you had to, the easiest way I found to do it was in the Mandalorian ring setup, is to create a separate project that was the setup, which brought the fixture and the actual model together, and then you could reference this point of rotation, which is calibrated, and this needed to be updated for every machine because the actual center of rotation differs from machine to machine just based on how the limit switches and all of that fun stuff are installed, and there's some tolerance in there. So we ended up having these tables, the B table with the collet, and we'd have to orient our component in there, and then from that setup you could reference that in your setup, and to do so you would identify your work coordinate system, which in this case would be a sketch point, and this sketch point happened to be, if we turn on things, that's the point of rotation for the machine. You couldn't change that, you always had to use that, and it had to be in that orientation such that the machine, when you post-process the operations out for the PocketNC, it would know specifically how it relates to the point of rotation for the machine in this specific orientation. That said, this is a virtual setup, and maybe the heights on the stock might have been different. If I measure from this virtual collet top to the top of this, it may, in the real world, this may be tightened down a little bit more, so it's a little bit off, and so this just lent itself to complications and offsets. So I would usually end up putting buffering the stock with a couple mil on top so that you had some material to burn through, so that you were always guaranteed that you wouldn't undercut yourself. So that said, it's kind of tricky for the remaining operations. In this case, all of the adaptive clearing and stuff, those were just a matter of identifying the tool orientation, in which case then you could change the orientation however you chose to, and for each operation you can modify that to suit your needs, and so that each operation could be from a different tool orientation, which, as you see, this one certainly was, but it was complicated. You always had to have these setup projects, and it made it tricky to get it all right, and there wasn't any wiggle room in terms of when I go to run on the machine, if my stock was a little bit bigger, a little bit smaller, in a different location, it wasn't centered. The collet made it easy because it was always in the center of rotation on the B table. But if you had, if you were using their clamp fixture and your material wasn't in the same exact location, it made it tricky. Okay, so that said, the Kinetic Control sort of opens this all up. Let's close these guys down because we're done with them. Kinetic Control eliminates all of that. So, and this is just a quick little two-dimensional deer. A lot of people make these on bandsaws. The only thing we have to do to support that is just identify any work coordinate system. So if we go directly from the design into manufacture and run a setup or create a setup and then identify that point of origin, this can be in any orientation that I want, because when I touch it off in Kinetic Control, I'll be able to identify and zero out each of those axes per my needs. And so in this case, I've got a stock block here that I'm going to be milling from, and I'm just identifying that top left corner in that orientation as the XYZ work coordinate system. And then from there, pretty much good to go. The stock, I'm just using the exact dimensions of it. The only thing you really have to do is identify the post-process. So your work coordinate system offset is what will determine whether you use a G54, G55, things of that nature. 0 and 1 will be G54, 2 will be G55, and so on and so forth. So once your setup is configured like that, then it's just a matter of us adding all of our operations to it. And they don't really care about the center of rotation for the machine or anything like that. And in each of these operations, I'm specifically going in to the geometry tab again. Like, well, this is the first operation, so there's no change to the tool orientation. It's going to just mill it the way that it's oriented. But in subsequent operations, I'm milling from different angles, so I do go in here and change the tool orientation, and you can do that whatever suits your needs. Use the Z and X axis, or you can, manipulate it using these handles. You can change the tilt and degree, so I could have, just rotated this and changed that to change your orientation of your tool. And so once all of your operations are configured correctly in the proper orientation, and you've adjusted them to have the correct tool orientation that you want, then you just post this out. And posting it out is just a matter of using a new CPS. So if you were to process this, there's a new CPS that's not yet posted to the Fusion 360 library, but you can download it from the PocketNC, and it's called PNC Kinetic Control. That's a CPS file, and you can upload that and use it directly. And then once you're using that, the only thing you have to be aware, there's a couple settings that are critical to make sure this all works correctly. One is select your machine. Is it a 210? Is it a 250? Identify that. Next, you'll want to ensure that the rotated work offsets is using G59.3. So that by doing that, you're basically saying use G59.3 if any of my operations need an alternate work coordinate system. And so for all of these operations that I set up the tool orientation, it's going to use G59.3 to dynamically configure that and use that for those orientations. Safe retract, so we leave it G53, and then the only final thing is TCPC mode. Make sure that that's enabled. Because these are all gray, those are all defaults. If I change it, you can see it turns blue. So anything that's changed will be highlighted in blue. So you can see I didn't change anything other than the machine model. So as long as you accept all defaults and use the V210, and you can confirm that these values are where they should be at G59.3 for rotated work offsets, and use TCPC mode, and then you can post that out. Posting it out in whatever format it supports both millimeters and inches, so you have the latitude to do that. You don't have to use inches. And that will generate the G code with all of your tool changes, which in this case we're all using the same end mill, so we're good to go there. Don't have to worry about changing that. Post it out, get your NGC file, and then we'll load that up on the machine. I'll show you how to zero out that work coordinate system. Alright, so let's export that, and we'll hop over to the machine interface. Alright, over in the machine interface, we've loaded it up, and we're looking at the default setup screen. Here's where we'll zero out that G54. So in order to do that, first we're going to home all, make sure all of those orientations are correct and homed and prepared for our setup. Alright, so now we'll need to configure the X, Y, and Z orientation and zero out the G54 work coordinate system. With the tool 1 selected, this has the correct offset, and we'll see that tool length is identified as such. And then it's just a matter of us using these and or the hotkeys to adjust our X, Y, and Z axis. Manually touch off. So in this case, I'm just going to touch off on those. And to do that, we're going to move the Y. Then we're going to move the X. Move the Z. And now I'm using the brackets to change the resolution. Alright, I'm going to use a piece of paper just to identify and touch that off. And then move it back in the thickness of the paper. Alright, so that's our Z. With our Z touched off, we just click on this button here, set our DRO to 0 for G54. You can see that the offset was updated for G54 and our Z-axis has been zeroed out. And we do that for both the Y and the Z-axis. So for the Y, I'm going to move up a little bit, get that exactly where I want, and I'm splitting the difference on this tool here, using this as a highlighter really to show me my tool and the edge. Now, this isn't a super critical zero. I have some stock to buffer me here. So that's about split. And then once I'm happy with my Y0, I click on the G54, set Y DRO to 0. Now if I were using an edge finder, I can split the difference on the thickness of the end mill, or the diameter of the end mill, and that would set it correctly. But since I'm just eyeballing this on the edge of the stock, then that's going to calculate it for me. Now, lastly, I need to move over and get my x-axis. Let's go there. Now I'm just using that as a flag so that I can see the edge. I'm actually standing a few feet away from my machine. And we're almost there. All right. Split the difference on that edge for my bit diameter. So the last thing I'll do is, on the x-axis, click on set X DRO and leave that new value to 0. Now you'll see our X, Y, and Z are zeroed out and we're good to go. Tool 1 is selected, so we're ready to go. Next, all we have to do is, so I can hop over into manual and I can go to quick access just to confirm, and I could say touch work home. Now if I click that, it should fly up there and touch the exact 0 where I zeroed it out, and then return to a safe distance. Now you can see that looks good. It's all perfect in that regard. And so next, all we have to do is just go into production. What we'll do is upload a file, select your NGC file, get progress as the file is being uploaded. Now that the file's been uploaded, we need to actually select it so that it knows we want to actually perform this operation. Click on the little open file or folder icon. We can select that item itself. Then the G-code is loaded up. And this G-code is pretty lengthy, so I won't scroll too much through that. But now we're ready to go. We've homed. It's just a matter of hitting cycle start and stepping through this. That's all there is to it. So using the new Kinetic Control machine interface, it's just a matter of touching off on our X, Y, and Z work coordinate system origins that we want. And that's based on where the stock is mounted on our device. Depending on your fixture, you may have it in all sorts of orientations. Now that we're all good to go, we just hit cycle start and we'll perform this operation. That's Kinetic Control in a nutshell. In terms of being an upgrade for the machine, I think it's pretty cool. It's got a lot of potential, and I can see how they'll expand upon it in the future as they build machine capabilities. You know, often when I'm working with my machines and you're fixturing your stock to your work table, often it's not exactly precise. Sometimes you have a larger piece of stock than you planned on, or the orientation and positioning of it on your fixture isn't exactly desirable. So hopping back and forth and having to manage that virtual point of rotation in relation to the physical setup on your machine can be complex and tedious. And so with the Kinetic Control environment, it gives you a lot of flexibility in how you can use it. Now, is it worth it for you to upgrade? I think that piece of capability alone makes the machine much more forgiving in terms of how you set up your operations and your tool paths and actually execute them on the machine with offsets. It affords you a lot of room for adjustments. And in my case, you know, I love it. I think it's useful. It was a little pricey, I think, for most of us that are upgrading to it, when that's really the only core feature that you'll be getting out of it. But keep in mind, it's going to make the machine easier to use, a little more forgiving in regards to your setup and your execution of, you know, milling parts on the machine. So I think that's worth its weight in gold, if you ask me. But, you know, that's up to you. It depends on how you use the machine, what you use it for. It makes 5-axis much easier. You look at some of my older, you know, 10 points to 5-axis milling, it's complicated and there are lots of nuances and lots of little gotchas that you have to be aware of. Here, as long as your toolpath and your work coordinate system index is set up correctly on your setup, everything else is the same as any 3-axis CNC. So that's kind of nice. Touching off on the machine in 5-axis, their interface makes it simple and easy to use. So all things considered, I think it's a good upgrade. It's reversible. If you end up not liking it, you can just take the SD card out. I haven't tried it, but they've mentioned that you can remove the SD card and revert back to your original environment. This is a 32 gigabyte SD card on the install, so it adds some additional memory for program storage and all that fun stuff, and expansion down the road, which is, we'll have to wait and see what that means in terms of capabilities that they provide and extensions that they deliver on. That said, that's going to do it for this video. Hopefully it was useful. If you have a PocketNC, check out this environment. It's and the machine interface is pretty cool. For me, it was a painless upgrade. It didn't require any troubleshooting per se. I just had to wrap my head around the new process, and it's much easier than the previous one. So give it a chance, and if it's going to be valuable for you, then it's probably a good upgrade for the machine. Add new life and new capabilities. If you like this particular video, give it a thumbs up. If you're new here, then subscribe to the channel, ring that notification bell. I'll keep you informed on future updates. In the meantime, be safe, have fun, and I'll see you next time. Hey, if you like the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.